Hey everybody, this is Chris McClure, and we are going to go through another section from the textbook, Section R.2, in our quest to review some basic ideas of algebra so that we can be on a better footing when we actually start the actual material for the course. And so we're going to now take a look at the material in section R.2 in the textbook. And this is going to go pretty quickly. I'm not going to spend a whole lot of time here. You should have seen this material already, but we're just going to discuss it anyway. So here we go. Let me go ahead and pull up my pen. See, what color do I want today? Let's see here. Let's go with black. All right, so here we go. So we're going to hit a bunch of topics, starting off with the real number line. Now, here we are representing the entire set of real numbers on this horizontal line that goes from left to right. As we go from left to right, we are increasing in value. You see this arrow tip right here. That points in the direction of increasing value. Somewhere in the middle on this line segment, we also have the origin, where we have the number 0. And we also use the letter O to represent the origin. Now, every real number is represented on the real number line. We typically place tick marks for the integers, or for every other integers. We can even make a tick mark for every 5 integers or whatever. But make sure that the scale is consistent. The scale is just going to be the distance to go from one number to the next. In other words, 1 unit. So if we're going to go from 0 to 1 in this distance, that has to be the same distance as we go from 1 to 2, 2 to 3, and so forth. And same thing in the opposite direction. Okay. Also, we can locate any other real number besides just the integers on the real number line. For example, for fractions, you just go the appropriate distance in between the surrounding integers. For example, the fraction of 1/2 is going to be half of the distance between 0 and 1. Or -3/2 would be half the distance between -1 and -2. For example, you can locate any irrational number, like for example, square root of 2 is right here, because we know square root of 2 is about 1.4 ... And so square root of 2 would be about 4/10 of the way between 1 and 2, for example. So you see here in the yellow box, we've got every real number is associated with a point P is called the coordinate of P. So here's a point P, and then basically you compute the distance between the origin and that point. And that distance, that real number distance, in other words, the real number that you assign to that point is called the coordinate of the point P. And the line whose points have been assigned coordinates is called the real number line. Right? We have the entire set of real numbers represented on the real number line. All the negative real numbers are to the left of the origin in increasing magnitude as you go to the left. Then we have the origin 0. And then we have all the positive real numbers that go to the right in increasing value. Remember, we can add and we could subtract any two real numbers. We can multiply and divide. Now, it makes sense for us to multiply two positive numbers to get a positive number. But we also have to remember that when you take two real numbers and multiply them together, that the result is also going to be a positive number. And if you take a positive times a negative number, the result is going to be a negative number. All right, so that's something to remember. All right, let's talk about inequalities real quick. We can compare the value of two numbers and state that the relative value by indicating some sort of inequality sign in between the two numbers. We might say that some number A is less than some number B by using this symbol right here, where the little small pointy end will point to the smaller number, and the larger part of that inequality sign will point toward the larger number. Otherwise, the two numbers are equal, or A is larger than B. And this, for each of these numbers line, this is what it looks like for these three different systems. If A is smaller than B, then A is going to be the left of B on the number line. If A is equal to B, then the coordinates are the same for those two numbers on the number line. If A is greater than B, then A is to the right of B on the real number line. All right, so 3 is less than 7. Negative 8 is greater than negative 16 because of the fact that negative 8 is to the right of negative 16 on the number line. Negative 6 is less than 0 because negative 6 is to the left of 0 on the real number line. Negative 8 is less than negative 4. 4 is greater than negative 1. 8 is greater than 0. Hopefully all these make sense. If we say that A is greater than 0, A is positive, where A is some number, right? A is some positive number if A is greater than 0. A is less than 0 means that A is a negative number. Suppose that I want to graph all the numbers that are greater than 4. In other words, graph the inequality x greater than 4. So how do we do that? Well, here's the number line. Locate positive 4. Here's positive 4. Now, we're not going to include 4. We're just interested in all the real numbers that are greater than 4. So that's why we use this open parentheses. Now, it's also okay with me if you use an open circle. An open circle would be perfectly fine as well. An open parentheses or an open circle works just fine. So this indicates all the real numbers greater than 4, but not equal to 4. Or if we want to graph the inequality x less than or equal to 5, well, we're talking about the set of real numbers who are either less than 5 or equal to 5. So we use either a square bracket pointing in the direction that the rest of the numbers are, or you can also use a closed circle like that instead of the bracket. And then, of course, with the shaded part of the real number line indicating the numbers that are less than 5. All right, so just make sure that you know how to graph inequalities. Let's review how to find the distance between two numbers. Look, folks, the distance between two numbers is just how many units they are away from each other on the real number line. So if you want to talk about the distance between negative 4 and 0, it's just 4. Or the distance between 0 and 3 is 3. It's just going to be some non-negative quantity. In other words, we're talking about the absolute value. Now, when we take the absolute value of a number, we're just counting the distance or figuring the distance between that number and 0. All right, so here's the absolute value bars that you place on either side of the number in order for you to take the absolute value of the number. Now, the absolute value of a number is always going to be either positive or 0 only if the number that you're taking the absolute value of is 0. The absolute value of a number is never going to be negative. But if you take the absolute value of a negative number, you'll have a positive number. Okay? Absolute value of 8 is 8 because the distance between 0 and 8 is 8 units. The absolute value of 0 is 0. Absolute value of negative 15 is positive 15. Okay? All right. So, just like the slide says. Moving on here. Now, using this notation, we're just simply saying that the distance between 2 points P and Q is going to be the absolute value of the distance between their coordinates. And it doesn't matter if you have B minus A or A minus B. Because remember, when you take the absolute value, you'll still take the positive of it, whether the quantity that you're taking the absolute value of is either positive or negative. So absolute value of B minus A is the same thing as absolute value of A minus B. So that means the distance between P and Q is the same thing as the distance between Q and P. Moving along here. Now suppose that we've got points P, Q, and R with coordinates of negative 5, 7, and negative 3. Let's go ahead and take a look at the real number line. Here's P. Remember, P is negative 5, so there's negative 5 right there for P. R is negative 3, so there's R at negative 3, and Q is at 7, so here we are. There's Q at 7. Now, if you want to find the distance between P and Q, well, there's P and there's Q. How many units are there between P and Q? So you could either take 7 minus negative 5 or negative 5 minus 7 and then take the absolute value, which gives you 12, either way. If you want to find the distance between Q and R, well, here's R, there's Q. Again, count the number of units between those 2 points. 7 minus negative 3 is 10, or negative 3 minus 7 is negative 10. The absolute value thereof is 10. All right? That's how you do it, folks. That's how you find the distance between 2 points on the line. Let's talk about evaluating algebraic expressions. Remember, evaluating means finding the value of. And remember what an expression is. It's just some combination of numbers and variables. And when we evaluate an expression, we just plug numbers in for the variables and simplify. So for example, if we have x plus 3y, and we know that x is equal to 3 and y equals negative 1, we just plug 3 in for x and negative 1 in for y, just like we did here, and then see 3 plus negative 3, right? We get negative 3 because 3 times negative 1 is negative 3. 3 plus negative 3 is 0. So the value of the expression x plus 3y at x equals 3 and y equals negative 1 is 0. All right, let's do these other ones. 5xy, you plug in 3 for x and negative 1 for y. 5 times 3 times negative 1 gives you negative 15. Or if you got 3y over 2 minus 2x, remember you're going to figure out what 3y is. You're going to figure out what 2 minus 2x is, and then you'll divide as your last step, following the rules for the order of operations, right? So you plug in negative 1 for y, and you plug in 3 for x. And simplify. 3 times negative 1 is negative 3. In the denominator, you have 2 minus 2 times 3. 2 times 3 is 6. So what you got there, 2 minus 6 is negative 4. Negative 3 over negative 4 is 3/4. And then finally, we have the expression absolute value of negative 4x plus y. So we're going to figure out what the value of negative 4x plus y is, and then take the absolute value of that result. So plug in 3 for x and negative 1 for y. You have negative 4 times 3 is negative 12, plus negative 1 is negative 13. Absolute value of negative 13 is 13. All right? So there, we're evaluating expressions. Just plug it in the numbers and simplifying. Now, when you have an expression, sometimes it's important for us to know what numbers can you not stick in to the expression in order for that expression to make sense. And that set of numbers that are allowable is called the domain. And for our purposes, usually our domain is going to be all the real numbers minus or except for the real numbers where it doesn't make sense, where that function will be undefined, so to speak. We'll talk more about functions later. I should say more like expressions that are undefined. So for example, 5 over x minus 2. Now we know that fractions are undefined when the denominator is equal to 0. Now x minus 2, you see there in the denominator, is 0 when x is equal to 2. So when x is equal to 2, this expression is undefined. So that means that 2 cannot possibly be an allowable input. So 2 is not in the domain. Otherwise, any other value for x is good. So one way that we could write the set of numbers that is allowable, in other words, the set of for the domain is given by the set builder notation, x such that x is not equal to 2. Okay? For example, here's another example. Here we have this formula that relates the circumference to the radius of a circle. All right, we probably remember this one from a previous class, that the circumference of a circle is going to be 2 times pi times the radius of that circle. And we know that the radius times 2 is equal to the diameter. So, and we know that the circumference divided by the diameter is always equal to pi. So hopefully this equation makes sense. And we know that the diameter is equal to 2 times the radius. All right, so if we wanted to say, hey, C is some function of R, what is the domain of this function? Then R is going to be the radius. Now, it doesn't make sense for R to be negative. And it doesn't make sense for you to have a circle with 0 radius. So only the set of positive real numbers would make sense as the set of allowable inputs to this expression or this equation. All right. Now, let's review exponents, okay? Now, remember, exponents come from repeated multiplication of numbers. So you have some number a raised to some power n, and that means that you have the number a multiplied by itself many times. You have n factors of a. So, for example, you might have 3 to the 4th power. That means 3 times 3 times 3 times 3. You have 4 factors of 3. For example, remember that any number raised to the 1 power is just itself. Any number raised to the 0 power is 1. But we don't know what 0 raised to the 0 power is. So that's kind of an undefined sort of expression. Okay. Let me erase that ink here. Also, if you have a negative exponent, that basically tells you to invert the expression and then raise it to the power that you had taken the negative of in the expression. So a to the negative n power is 1 over a to the n. So that means that 3 to the negative 4th power means 1 over 3 to the 4th power, for example. So if you have 2 to the negative 3 power, that means 1 over 2 cubed, which is 1 over 8. Or if you have x to the negative 4 power, that means 1 over x to the 4th power. If you have 1/5 raised to the negative 2 power. Now, you could write this as 1 over 1/5 squared, which is 1 over 1/25, which is 25. Or you could also think about, hey, this negative exponent In fact, this little negative symbol means to take the reciprocal of this expression here, and the reciprocal of 1/5 is 5. So you can think about 1/5 to the negative 2 means 5 to the second power, which is 25, okay? Moving along here. Now, these are the various laws of exponents that I'm sure that you've seen before that tell you that, how you can handle these various exponential expressions. Here, if you've got a common base of exponentiation and you are multiplying a to the m times a to the n power, where these two numbers are the same, but the exponent may or may not be different, then the result will be the same base of exponentiation, but raised to the sum of the two exponents. Here we've got the like the multiplication rule that says if you have a to the m power raised to the nth power, that means that you multiply the exponents. If you have the product of two numbers raised to power, that could also be written as the product of the powers. So you kind of think about this third rule that says the power of the product is the product of the powers. Or the the quotient of the powers is the difference of, you take, sorry, I'm trying to make some interesting sort of way of remembering this, but basically this kind of goes along with this top one here, but instead of multiplying, you're doing a division. So instead of adding the exponents, you subtract the exponents. And then if you have some fraction raised to the nth power, then that would be the quotient of those powers here. All right, so just stuff that I'm sure that you've seen before. Let's just look at some quick examples. Here you've got x to the negative 3 times x to the 5th power. Because you have a common base of x, then you'll just add the exponents, negative 3 plus 5, which is 2. So you have x squared. Part B, you have x to the negative 3 power squared. So using this multiplication principle, you'll just take 2 times negative 3 to give you your new exponent. So this is x to the negative 6 power, which will be 1 over x to the 6th if you are going to use positive exponents. Here you've got 2x raised to the 3rd power, and then using this rule up here, that means 2 cubed plus x, or times x cubed, but 2 cubed is 8, so you have 8 times x cubed. For part D, you have 2/3 raised to the 4th power. Now you could write that as 2/3 times 2/3 times 2/3 times 2/3, or you could use this rule here that basically says that this will be 2 to the 4th over 3 to the 4th, which would be, 16 over 81. For part E here, for this guy right here, you can use this rule up here that says that you'll subtract the exponents. So you have x raised to the negative 2 minus negative 5. But negative 2 minus negative 5 is negative 2 plus 5, which is 3. So x to the 3rd power. All right. Let's talk about square roots. Remember, the square root of a number is a positive number, or at least a non-negative number, whose square is equal to the number that you're taking the square root of. All right, so we use this symbol, the square root symbol. Sometimes we call that a radical. Okay. So here are some basic ideas and concepts from square roots. As long as we're staying in the real number system, the negative numbers don't have square roots. When we start talking about complex numbers, then we'll talk about how the square root of negative 1 is equal to the imaginary number. For example, But until then, negative numbers don't have square roots. Square root of 0 is 0. And by the way, you see the word principal. That basically means the positive square root. You know, if you look at 4, for example, a square root of 4 is 2. But also negative 2 is a square root of 4 because negative 2 squared is 4. But when we talk about the square root of a number, we're talking about the positive number whose square is equal to the number that we're taking the square root of. In other words, the principal square root. All right, so the principal square root of a number is a positive number. Okay? The square of a square root is the number itself. So the square of square root of 2 is 2, and so forth. Square root of 64, well, what number squared is equal to 64? And the answer is 8. So square root of 64 is 8. But if we were to solve the equation x squared is equal to 64, then the answer would be square root of 8 and the negative square root. Oh, I'm sorry, the answer would be plus or minus the square root of 64, which is plus or minus 8. All right, part B, the square root of 1/16 is going to be equal to 1/4 because 1/4 squared is 1/16 and is positive. The square root of 1.4 squared is going to be 1.4. Right? Squares and square roots cancel each other out. They're opposite operations of each other. Also remember that the square root of the square of a number is going to be the absolute value of that number. So if you want to take the square root of 2.3 squared, the answer is going to be 2.3. The square root of negative 2.3 squared is still 2.3. And the square root of x squared is absolute value of x. But square root of x squared is just x. Just make sure you see that distinction. All right, what happened here? Let's pause, and I think that my computer froze on me, or at least the slides did. Just a second. Okay, folks. Sorry about that pause. Um, Actually, I thought I had actually paused the recording, but obviously there was about 5 minutes or so where nothing was going on because I had to uh, stop the PowerPoint and restart the program. And then I walked away for a few minutes so I could stretch my legs. I've been driving all day. I'm sitting in Knoxville, Tennessee, getting ready to go eat dinner. But I wanted to visit with you guys for a few minutes before I go eat. All right. So we restarted the PowerPoint. Let me get my pen out. I'll use the red ink. We're almost done with this anyway. We were talking about exponents here, as well as square roots and the interplay between them. Now, the square root is kind of like the opposite sort of operation as the square of a number. So the square root of the square of a number is going to be the original number. But when you take the square root of the square of a number, the result is going to be actually the absolute value of that number, because you're squaring that number first, which will give you the positive of that number. And then when you take the square root, you're getting the principal square root, which is always positive, unless you're taking the square root of 0, which is 0. It's never going to be negative. So the square root of negative 2.3 squared, well, that's just really the absolute value of negative 2.3, which is 2.3. The square root of x squared is absolute value of x. Whatever that is, it's just the absolute value of x. Now let's talk real quick about how to use your calculator to evaluate exponents and square roots. Now, let me just point out that by now you should be getting a calculator if you don't have one already. I've got my TI-84 calculator here. Now, you can access the square sign up here, or you can just raise it to the second power. So you could do 8 squared, for example, just by hitting 8 and then this number, or this button right here. That'll give you 8 squared. Otherwise, if you want to do 8 squared using this symbol right here, this exponent symbol, you can do that as well. So there's 8 raised to the second power. Gives you the same thing. For example, or 2.3 squared. Now, if you want to take the square root of a number, you have to access it by hitting, the square root symbol. So you have to hit second and then this button right here. So if you want to take the square root of 4, then you do it that way. Now, if you don't have anything else to add under the radical, then you can go ahead and right arrow to get out from under the radical. And then that'll compute your square root. If you want to take the square root of an expression, you could do that as well. So if you want to take the square root of 2 squared, then that's fine. Or if you want to take the square root of negative 2 squared, you can input it like that. And the result is going to be 2, for example. All right, so there. Now you know how to evaluate exponents on your graphing calculator. So now let's talk about scientific notation real quick. We use exponents to help us deal with extremely small or extremely large numbers. So here's what we do. You take some extremely large or extremely small number and write it to where you have some number that's between 1 and 10, like you see here, and then times 10 raised to some power, either positive or negative power. All right, so let's just review how we can go back and forth between the expression the number in normal notation or standard notation and scientific notation. So here we go, we've got 9,582. How do we write that in scientific notation to where we have 9.582? Remember, you need to have your decimal point just to the right of the ones position. All right, and you can't have any numbers in the tens position right here. So that means that this number right here has to be between 1 and 10, less than 10, greater than or equal to 1. But then how many decimal places did we need to go from, and here's the decimal places, it's right there. We needed to go 1, 2, 3 decimal places. So that means we have times 10 to the third power. This exponent here will tell you how many decimal places that you needed to go from right to left in order to place this in scientific notation. Okay, let me go ahead and erase this ink. And let's look at the answers here. So the 9.582 times 10 to the third power is what this number is in scientific notation. What about the part B, the 1.245? Isn't that already in scientific notation? It is. And what about the 0.285? That's not in scientific notation, but because you have to move the decimal place over 1 unit to the right. So, which means that once you have the 2.85, then you write that times 10 to the negative 1 power. Negative 1 because you had to move the decimal place 1 unit to the right. Or you have the 0.000561, so you have to move that decimal point over 1, 2, 3, 4 units to the right. So you have 5.61 times 10 to the negative 4 power written in scientific notation. And then we can go in the opposite direction. If you have your number written in scientific notation, then you can express it in standard form. So you have 2.1 times 10 to the fourth power, and so instead of going from right to left, now you're going from left to right. Put a bunch of zeros to the right and then count out 4 decimal places. So here's your decimal place or decimal point, and then you go 4 units to the right. So that'll give you 21,000. Okay? Or you have 3.26 times 10 to the negative 5 power. That means that you're going to move a decimal point 5 units to the left. So you'll write your 3.26 with a bunch of zeros to the left, and then you count up 5 spaces for your decimal point. So that'll give you your 0.0000326 as the number written in decimal form. Okay, because there are 5 decimal places between here and there. Or you have 1 times 10 to the negative 2 power. All right, so with that negative 2, that means you have to put like 2 zeros to the left and then count your decimal point 2 units to the left. Okay, 0.01. So if you have, for example, the number 0.00001 centimeters, what is that in scientific notation? Well, just count 1, 2, 3, 4, 5. That'll be 1 times 10 to the negative 5 power. Or if you have 1.97 times 10 to the 8 power for square miles for surface of the earth, can you write that as a number written in standard notation? Well, then just write 8 zeros to the right of the 7 there and start counting. And so you go, there's your decimal point. You go 1, 2, 3, 4, 5, 6, 7, 8. Boom. You're done. So actually you need to put 6 zeros. So 197 million is the same as 1.97 times 10 to the 8th power. Let's talk real quick about how to use scientific notation on your calculator. Now, if you've got a TI-84, then look for this button right here where you see the comma. So if you want to do 1.97 times 10 to the 8th power, then just hit the second button and this button here. So there's 1.97 times 10 to the 8th power. Okay? So using this little E button. Yeah, I know it's kind of strange. It shows an EE on for the name of the function, but how it displays on the screen is just with a single E. But it still means times 10 raised to the whatever number that follows. Okay. All right. So practice that. I think we're done with section R.2. I see that now it's Friday evening, May 24th, and I see that a lot of you have, at least one of you have gotten enrolled in my math lab, and that's good. That means that there's about 7 more of you that still need to get enrolled in my math lab. Please do that as soon as humanly possible. I should be on the DMAC campus first thing Tuesday morning, around 9 or 10. So if you are in the local area and you have questions on how to do it, I'll be in my office, okay? Room 10A in building 4. All right, but I'm probably not going to record another lecture until Tuesday so that we can enjoy our holiday weekend. Please send me an email if you have any questions or problems with anything regarding the textbook, regarding access to Blackboard, or viewing the lectures, or my math lab, or whatever, okay? Please let me know if you have any questions. Otherwise, please keep moving along. In fact, I already do have homework posted for section R.2, but a lot of you like to work ahead, so I'll go ahead and post a couple more homework assignments from section R3 and R4. Okay, so you can work ahead if you choose to. All right, take care, good luck, and I'll see you next week.